Hello everyone and welcome to our TRUMPF webinar on the subject of bending programming and how we get from the geometry to in C program faster than ever before. In this webinar you will learn how to use the new direct editing functions within Bend and how to take forms into consideration and how to use the appropriate bending strategies in order to create practical in C programs. We will also learn how to add special tools and special materials. Thus, the bending sequence and the tool setup and the baggage finger strategies of unfolds can be optimized for production the fastest way possible. Through the immense time saving, using the automation, the programmer only has to intervene where it's necessary. And therefore, with TruTops Boost, you generate bending programs faster and reduce the non-productive time of the machine. So let's remind ourselves how TruTops Boost is structured. Basically, TruTops Boost is the sum of the Boost technology and the new operating philosophy. So the Boost technology contains all the automatic calculations, automatisms, and the whole new software architecture. The operating philosophy contains the division of this programming process into two levels. The first one is called home zone. That's our central control level and order management, and it contains a quite prominent boost button. And by pressing the boost button, you get to your in C program with one click. The text zone is our interactive level. So it's possible to interactively change and adjust the proposed solutions and technological solutions, and you're also able to create or edit or to repair your own 3D or 2D CAD models. To point out some highlights of the new TruTops Bend, of course, the whole new boost button and the automatic programming helps you to reduce your non-productive time. You can work in parallel and continue doing other things such as creating new models, geometries, or repair other geometries, or just program another technology. Within Bend, we also take some forms into consideration for collision checking. We also are able to generate various bend solutions for different bending machines, and basically you can decide within the production which NC, so which program to take depending on the available bending machine. You always keep track of your changes within the home zone. So if you have generated a bending solution and in case of changing your model, your CAD model, for example, if there are some design changes, you always get a warning saying that the bending solution is not based on the latest design. A whole new way of working is our direct editing features. So you can just grab a tool or the baggage fingers or the part and just move it or adjust it or change the tool, for example. You can also very easily implement special tools such as window tools or any other tools you create, and you can use them within TruTops Boost Bend. The automatic sheet metal correction of the geometry is new, and the new Bend helps you to solve problems and it even propose possible solutions. And last but not least, it's very easy to create special materials and to introduce your own shortening values. So let's get started and switch over to TruTops Boost Bend. So first of all, you see the user interface on the left side. We are right now in the category order. in the center there's our order list, and on the right side the detailed view of our selected orders. So first of all, we import some files, and as you can see, there's a preview window for the supported formats, and you can even check whether that's the right part. And we just batch select all the parts and import them. So after importing, we just assign the finish date. It would be, let's say, next week. Part quantity should be inserted and the customer information. So let's assign all tools for the unfolding, and we also assign our material, and we would use our favorite bending machine. So we save our changes and switch over to single part category, and I would like to add 2 more machines for 1 part. So that part would be, yeah, multi-solution 03. What I'd like to do is I would just add 2 more machines. So that's a TruBend 3180, and I add another one, 7036. So the purpose would be an automatic generation of BNC programs or bending programs for all my machines within the production, and to decide later on which NC I would take. Alright, now I select all my imported parts and boost them all in order to get the automatic bending program. So meanwhile, we can create a new part, and I will give it a name, assign a customer, and again assign the material information. Can even set the thickness and my tool list, and let's say it would be for 1 bending machine. So I open it up. So probably you have used many times BendGraph on the control of your bending machine, and I would like to show you how to create profiles in a very easy and fast way within TruTops Boost. So we switch over to profile, we sketch few lines. So the profile depth would be 100 mm, the first line length would be 50, and I just switch to my outside dimension, and you have always take care basically from where your point starts. So the second line should be, let's say, 125. Then if you want, for example, to grab the other dimension, outer dimension, you just press Shift and you set the point there. So the outer dimension would be 250. My next line would be 95 from the upper side. So my next line would be 50, and alright, what I'd like to do now, with an angle of 135, the line length should be 70, let's say. But now you have, of course, to be very careful, because if I measure that line, so I can switch on the 3D view, it doesn't look too bad. But what I'd like to mention, for example, if I measure that line by pressing E, that line is 7058, and again 7058. So if you remember, we should of course dimension that side, that line, basically from that crossing point. So if you extend tangentially those two lines, and we'll do that by setting the line to layout curves. So I'll just create a loop. So, and draw also another line with the length of 70 mm. And you see that, of course, the line differs, and we correct it by just pulling the side to until that point. So up to that point. And we have dimensioned right now the line correctly from that point to the outer side, and it would be now 70 mm.
So in the next step, I would like to create a hem. For that function, I just activate the pull tool, click on the inner edge, click on juggle or hem. Before that, I adjust my options and would like to create the hem within and the outer dimensions. Keep the outer dimensions, so 70 mm. Well, so if I pull in, I can type in my dimension. So I put in 29, and you see that the length is 30 mm. So, but another problem is, of course, the radius of 1 mm, the thickness is added, but we'd like to keep the 70 millimeters outer dimension. So how do I correct that? It's very easy. You activate the move tool, place the anchor on the outer radius, and grab the point where the 70 millimeter line is and type 0 in, and now we have kept the outer dimension of 70 millimeters. So if you'd like to create a hem with a gap, an open one, you see again that here's our point, that the radius of the gap is added. So again, in order to correct that, I activate the move tool and place the anchor on the outside, grab my point, and again type in 0 with my ruler dimension. So now the radius is again within my dimension, and still the length of the hem is 30 mm, and it's has got an opening of gap of 2 millimeters. So if you would like to, let's introduce a step bending. So I just click on the bend, type in a bend radius, let's say 50 millimeters, and I would like to do it in 5 bend steps, but of course you can increase it if you like. And of course we could use one tool, one punch tool or die, but I'd like to do it in bend steps so we see how it will work out. And in the last step, I'd like to introduce some forms such as cups. Let's say height is 5 millimeters. So the first dimension, let's say, is 10. The other one is 20 millimeters. And we select a plane and insert them. Click on the check mark. And it's, again, we see how they will be processed. And again, it's what you can even do is we can insert normed parts, like for example that part, and see how we handle that. So if I pull it into position or move it, So again, I displace the anchor on that side, activate that arrow, activate my ruler and say that it's 0 mm, and we can even move it a bit further. And of course, if I would validate it, it would say the system will recognize it and will say that the part is an assembly. So that's why I combine both parts by pressing Alt. And you see that we do have one solid now. And I have to identify it as a form, of course. You see it gets a form feature, and there is a function called consider forms before or after bend process. What does it mean? It's very easy. If you want to have special forms within your model, but don't want to consider it within your bending process, you can just click on the form and say that it will be introduced after bending, so that the bend program shouldn't consider it. We recalculate and generate another bending program.
So after validation, we get the right unfolding and we can create the bend program. And right now I have created already one, and we just start with the simulation and see how the part is being bended. You see that tool station, the bending sequence was calculated. Here's our 5-step step bend, and what we can do is there are no collisions, and basically what you can do, you can activate the baggage view, and for example, if you click on bend operation 3, the positioning, if you like, you can adjust your strategy and for the clamping with the baggage fingers, and you can do it for each step, but there's nothing to correct. So you see that the our big radius is automatically processed, and we're good to go. Of course, we could have set the property of that bending that it should be done with another tool, and for example, if I just select it and go to my overview, if I deactivate the filter that's here within the options, it's possible to select all the tools, and of course we could have done it with normal radius with R50. That's up to you how you depending on the tools you have and depending on the part quality you would like to produce. But those would be the possibilities with big radiuses. All right. Let's close the part and check other examples. Meanwhile, we see that all the parts which I have started have been calculated. So if I filter for today's modified, we see that only one part had a problem, and we can check it out later. But what I can do is I just select them all. Let's say not all, but all I don't want to modify, and release them. And we can even check for the multi-solution part. If I type in multi-solution, that all 3 programs were calculated, and I can release all the 3. And of course, they were all calculated with all tools, meaning that if you have different tools within your production for each machine, you have to decide which program to take, because of course the unfolding differs if the tools differ in diameter or in the radius. But if they're the same on each machine, you can release them all and decide later on during the production, depending on the availability of the machine, which program to take. So we open the next part. It's our it's a part with a slit, and that's basically that part. And we'll see how we can adjust our setup plan and our tools. So as we can see, there are two tools with a length of 100 mm each, and there is a collision statement, and basically that part or flange is colliding with the upper tool. So how we do create slits within our between our tools? It's again very easy. So if we activate the tooling plan, it's also new that you see the screen separation, and if you adjust anything with the tools, you can immediately simulate it. And it's new for the new bend. What I'd like to do is, so I set the tool to 100 mm and copy it. And I would like to adjust my second tool by changing the position. So let's say it would be 1704. So I moved it a little forward, but we still see that it would collide with the other side. So I need to adjust the length as well, and therefore I activate the pull tool and pull on that side. I just pull it enough in, and you see that automatically there were 245 segments created, and that's basically it. We simulate the result, and you see that the slit now is working, and we just get some collisions saying that the upper tool length is not sufficient, but as I know that it would be enough for me, I just ignore the warnings, and the overbending is alright. And basically I'm finished. So I have used the copy function of a certain tool. I deleted the original one, I copied the existing one, the neighbor tool, and I have shortened it by using the boost tool calling pool. And now we are finished. I generate the INC file, the new one. So I have optimized my tooling plan just with a few button clicks. And we close it. Well, we open up the part and see how we can improve or optimize the bending solution. So there's a warning saying that the height is inconsistent. That's why there's an adapter. We've got two warnings saying that the overbending and releasing, so during that process there is a collision, of course, so we slide sidewards the part out. I can just ignore it, and we are able to generate the INC file. But in that case, I don't like to use two tool stations, and what I'd like to do is I just change the bending operation. I basically use for all the three bending operations my first tool station, and just check whether the other operations are on the first. So the third I also would like to move. So that would be my first step. The second one would be deleting of all the 4 tools of the second station. Now I'm left only with that pair of upper and lower tool. So what I'd like to do now is I will replace that tool with a window tool I have created before. So I just extend that tool, center it, align it, and select here my window tool. And you see, it doesn't have to be realistic, but I have created that tool before and just pulled out a very big window for just to show you how it's could be done and what's the advantage of it. So I close my tooling plan view and just start the simulation, activate the side view. And you see right now the part would go in. So first one, second one is okay. There's still a gap, even if it's a very small, tiny one. But the problem would occur right here, and we see we have a window tool. There are no collisions. We perform a collision check, and we are good to go. There's a warning again within the process type of releasing, but that's how you use basically window tools, and we are now again able to generate the in-C file and have saved basically another tooling station, and of course it's easier and time saving for the operator. How to generate that tool? You start the data manager. You start the data manager, go into your dice, copy the existing tool, and right-click on your copy tool and edit it within the design level. And basically, you can create any tool which you, of course, have physically, and you can simulate, of course, the result within Bend. So in the last example, I would like to show you how to adjust, again, some tools in order to create a better program and safer one. So I go over to the Bend tab, and we see again that there are some warnings, but so if I simulate the solution, we see that a horn tool was used. What to do if the standard solution wouldn't propose that horn, but a normal tool, we just activate horn right, and you see that on the left side there's no horn, and of course there would be, if I simulate, there would be a collision at that stage right here, and you will get the warnings and the collisions. And it's of course very easy. You just click on the tool, you get a mini toolbar, and you activate on both sides the horns. If you would like to see how your other tools look like, you just hover again or left click on your tool, and here you get a preview of the possible tools you can insert. So that's for the upper tool, lower tool, the same. Just click on that arrow and you are able to select, with the image preview, a red tool. And the same within the tooling plan. If you expand that window you get a preview and can even select large icons and are able to select it via image selection. Alright, we again perform a collision check, and since we haven't changed anything because the horn tool was used in from the beginning, I just close the part without changing anything and release it again. So in the last example or subject, I just go over to material, and I'd like to show you the material database. And if you insert your own materials with your own shortening values, it's very easy. You just duplicate the existing material. For I have created a new one, so it's a 1.4501. It's a special stainless steel, and it's actually important to assign the normal material, so an existing one where bend deductions are available. And within the data manager, which is within the bend settings, you open it up and basically you put in your shortening values for that special material. So those were some topics from Bend which I wanted to point out. And so we have seen how easy it is to solve problems with the new TruTops Bend, how fast it is, and you save a lot of time, non-productive time at the machine if you program offline. And if you need to correct anything, it's very easily if you do it interactively. But of course, the automatic calculation helped us a lot and saved us a bunch of time. So in case of any questions, don't hesitate to write us. We are happy to answer them all. And just a preview for the next webinar, it will be laser programming and why is it easier than ever before. And if you have any ideas, just give us a short feedback. So thank you very much for watching, and I wish you a pleasant day. Goodbye.